Welcome back. Let's do another example on testing hypothesis. Let's say that each bag of cherry tomatoes is labeled 227 grams. What does that mean? It means that the mean weight of all these bags is 227 grams. The quality control manager picks a sample of 4 packs and finds that the sample mean weight is X bar equal to 222 grams. And also they let's say they found that the measuring equipment gives a standard deviation of sigma equal to 5 grams. So basically, we're assuming that the standard deviation of weight is 5 grams here. This is the population standard deviation, and the population mean weight is 227 grams, and we take a sample of size 4 here. This is the sample statistic. So we're gonna first thing that we need to do is set our hypothesis. Now the claim basically is that the mean weight is 227 grams. So the hypothesis, null hypothesis here would be that the mean weight is 227 grams, and the alternative hypothesis here would be that the mean weight is not equal to 227 grams, let's say. So that's the alternative hypothesis that we are choosing. Now, making this choice of alternative hypothesis then makes it a two-sided test. And let's say now we set the significance level, and so this is the standard for our, how small your p-value needs to be. So if the p-value is less than 5%, then we're going to reject the null hypothesis. If the p-value is greater than, then we won't be able to reject the null hypothesis. So we're setting the significance level to 5%. So now so what would be the p-value then? Well, remember, the p-value is the probability. So what is the p-value? Well, assuming that the mean weight is 227, what's the probability that the sample mean weight will take on a value value equal to or more extreme than the observed sample mean weight? This is so something. What's the probability of getting a sample mean more extreme than this one? Well, because we are doing a two-sided test, so then we're asking what's the probability that the sample mean is less than or equal to the observed one, but also the difference, the distance between the observed sample mean and the claimed population mean is 5. And so we also have to look at the event that X bar is bigger than 227 plus 5, which is 232. So the way I'm getting this 232, this is the observed sample mean, and the distance between the observed sample mean and the population mean is 5, and I'm adding 5 to 227 to get 232. So because our alternative hypothesis is that mean is not equal to 227, so the extreme could occur in both directions. So the p-value here that we're going to look at is the probability that X bar is either less than 222 or bigger than 232, assuming that the population mean weight is 227. So to calculate this probability, we have to first look at the distribution of X bar, and the distribution of X bar is normal with mean equal to the population mean, which is going to be this would be equal to 227, and the standard deviation would be sigma over root of n, which is 5 over root of 4, which is 5/2, because the sample size is 4 and the 5 is the population standard deviation. So basically then we are asking the p-value is the probability. So this is the distribution, this is the figure for the distribution of x bar, and 227 is the mean. This is a normal distribution, and we want to know what's the probability that the sample mean is less than 222 or bigger than 232. So basically the distance between 222 and 227 is 5, and then on the other side of the mean we add 5 to get to 232. So again, in this case we are doing a two-tailed or two-sided test. So what values of the sample mean are more extreme than the observed one? Well, these are the values. Values bigger than 232 or values less than 222, they are more extreme than the observed one. So so here is what we're doing then. So we want to know the probability that x bar is here or here. Now we're going to convert, we're going to look at the z-score. So the z-score is x bar minus the mean over sigma over root of n. So for 232, the z-score, so 227, the z-score would be of course 0. The 232, the z-score would be, so 232, here the mean would be 227. So if you look at for 232, what we're going to get is 232 minus 227 divided by, and recall that this was 5/2, right? The sigma over root n was 5/2, and that is equal to exactly 2. So the z-score of 232 is 2, and the z-score for 222 will be -2. So the p-value is the probability that z is either bigger than 2 or less than -2, and then that's the same as the probability, 2 times the probability that z is less than -2, because the probability of this event is the same as the probability of this event. So 2 times the probability that z is less than -2, and that's 2 times 0.0028, which is 0.046. So since the p-value is less than the significance level 5%, we reject the null hypothesis. Okay, so I want to end this video with a remark. So the confidence interval and two-sided significance test. So there is a relationship between confidence interval and two-sided significance test. So if you recall that for this same situation, for this same example, we calculated the 95% confidence interval in a previous video. So if you use this observed sample mean 222 and look at the 95% margin of error, and then you calculate the 95% confidence interval, you're going to get the interval from 217.10 to 226.90. And notice that the hypothesized mean value, that is the mean value 227, that hypothesized value is not in the 95% confidence. So 227, the claimed value of the population mean, doesn't lie in my 95% confidence interval. So that's another way of saying that's another way of seeing that the null hypothesis should be rejected. And for the 5% significance level, we found a p-value that was less than 5%, so we rejected the null hypothesis. So for the 5% significance level, the the hypothesis test that we are doing with 5% significance level, we could also do that by using 95% confidence interval. And if the claimed mean isn't there, that means we reject the null hypothesis. Now, if we change the significance level to, let's say, 1%, then we're going to have to calculate a 99% confidence interval and to do an equivalent test. So all I'm saying is that the test that we just did using significance level 5%, we could have done it by using 95% confidence interval. So if the 95% confidence interval doesn't contain the claimed mean, then the null hypothesis will be rejected at 5% significance level. On the other hand, if the 95% confidence interval contains the mean, then we fail to reject the null hypothesis at 5% significance level. Okay, so I'm going to stop here, and I hope to see you in the next video.